Welcome to AI Frontiers, the podcast dedicated to exploring the leading edge of artificial intelligence research. Today, we delve into the field of computational linguistics, a discipline that is fundamentally changing how machines comprehend and interact with human language. This episode is titled Decoding Language, the AI Revolution, covering 120 papers published between May 27, 2025, and May 27, 2025. This presentation offers an overview of the latest advances in computational linguistics. It aims to unveil the recent progress in how language and machines are interfacing. The discussion will include the exploration of AI's transformative role in understanding human language, key research themes, recent breakthroughs, seminal papers, and their potential influence on the future of AI. This sets the stage for a comprehensive look at the current landscape of computational linguistics. Computational linguistics is the science of understanding and computationally modeling human language. As an interdisciplinary field, it merges computer science, linguistics, and artificial intelligence. It models language computationally for both interpretation and generation, which enables a diverse range of applications, including chatbots, machine translation, and automated summarization. Its significance lies in the fact that language is fundamental to human intelligence and communication. One prominent research theme is Commonsense Reasoning, which aims to equip language models with everyday knowledge. The goal is to imbue models with the ability to reason in a manner similar to humans. Language models need to infer implicit knowledge and make plausible inferences about the world. The paper Language Models Are Noisy Thinkers, Controllable Mental State Planning for Commonsense Reasoning explores mental state planning within this context. The primary focus is on improving consistency and coherence in the reasoning chains generated by these models. Another significant research theme centers on bias and fairness in natural language processing models. There's a growing recognition that language models can inadvertently amplify societal biases. Research is being directed towards developing techniques to identify and prevent these biases from being perpetuated. The paper, A Novel Bias Evaluation Metric for Text Summarization Tasks, directly addresses the problem of bias in summarization tasks. The overall goal is to ensure that language technologies are equitable and do not discriminate against any particular groups. A third theme focuses on multilingual understanding, which involves bridging language barriers with AI. The objective is to create models that can effectively process text in multiple languages. This facilitates communication and knowledge sharing across different linguistic boundaries. The paper Zero-Shot Cross-lingual Transfer, Unlocking Language Model Potential highlights progress in this area. Researchers are exploring transfer learning and cross-lingual adaptation techniques to achieve broader multilingual capabilities. Key findings in natural language processing include improvements driven by strategic prompting and common sense reasoning, as seen in the paper Language Models Are Noisy Thinkers, Controllable Mental State Planning for Common Sense Reasoning. Additionally, new metrics are being developed to assess bias more comprehensively, an effort highlighted by a novel bias evaluation metric for text summarization tasks. Transfer learning has also been shown to enhance model performance in low-resource languages. Furthermore, pre-trained language models may require different architectural approaches to function effectively across different language families. Several key methodologies are used in this area of research. Fine-tuning involves adapting pre-trained models for specific tasks, leveraging existing knowledge to improve performance. Prompt engineering involves crafting inputs to elicit desired behavior from these models. Data augmentation uses synthetic data to expand training sets. Knowledge graph integration enhances accuracy and reduces hallucinations by incorporating structured knowledge. Manual annotation is still an important approach to build datasets, and creating custom datasets, however, can be extremely time-consuming. The research by Wan et al., titled Can Large Language Models Capture and Utilize Animacy Hierarchy and Semantic Understanding?, investigates the ability of large language models, or LLMs, to understand animacy hierarchy. The methodology involves controlled experiments and novel probing techniques designed to assess whether LLMs exhibit sensitivity to animacy. The results are mixed, showing some sensitivity but inconsistent application of animacy knowledge. The significance of this research lies in shedding light on the limitations of LLMs in fully grasping nuanced language understanding. The research by Zhang et al., titled A Novel Bias Evaluation Metric for Text Summarization Tasks, develops a new metric, BES, for evaluating bias in text summarization. BES measures both the magnitude and direction of bias using techniques such as sentiment analysis and topic modeling. Findings indicate that many existing models exhibit significant biases. The significance of this work is that it provides a tool for mitigating bias in natural language processing by offering a means to quantify and address it. The research by Kumar et al., titled Evaluating the Generalizability of Pre-trained Language Models in Detecting Hate Speech in Low-Resource Languages, assesses the effectiveness of pre-trained language models, or PLMs, in detecting hate speech in low-resource languages. The findings indicate that performance varies depending on the language and model, but that fine-tuning is a crucial step. Error analysis reveals that models often struggle with subtle forms of hate speech. This work contributes to the development of more effective hate speech detection systems, especially for languages with fewer resources. Future directions in computational linguistics include several key areas. Developing more explainable and interpretable models is crucial for understanding how these systems arrive at their decisions. Mitigating bias in both language data and algorithms is essential for ensuring fairness and equity. Creating more efficient and scalable training methods will allow for faster and more accessible development. Addressing the ethical considerations of AI in language is also paramount, as these technologies have the potential to impact society in profound ways. The synthesis of this podcast was created using Google's MODELS/GEMI-2.0-FLASH via the GPT model. The text-to-speech synthesis utilized DeepGram for audio generation. Image generation was powered by OpenAI. The synthesized content was reviewed by a human expert, but potential oversights may still exist. All references are provided for transparency to allow for further investigation of the topics covered. Stay updated with AI Frontiers. Subscribe to our YouTube channel, AI Frontiers, for daily insights. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archive preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by Archive Preprint Server.